Awesome. Thank you. God, I'm loud. God, no wonder you guys are in the back row. I'd be in the back row too. You may want to move on out. So first place, let me first welcome you to Cisco Live. My name is Hope Galley. I am the global leader for Cisco's service provider, channel, and ecosystem. I am pitch hitting for an individual who works in my organization who happened to have COVID. So that's why my name is not Jacky Lowe. So, and I got in at 2:30 this morning, so I am going to be ready to go. Before we get started, just let you know, I like to keep things interactive. So if you do have questions, please reach out to me as we go through. We have 15 minutes to 20 minutes together. So with that being said, I'm going to kick off talking about how we solve business problems with turnkey applications. And I'm assuming many of you are familiar with Meraki already. And so if we think about Meraki and everything we talk about around Meraki is around the dashboard. And the thing that has been so prevalent over the last 2 to 3 years with Meraki has been, how do we build upon the packaged APIs that we have in the Meraki product, and how do we bring that into utilizing ecosystem partners? So if you look at it, we have 2 different areas where we do API integration. It's our access products and our security and IoT products. And just know that the reason why we are scaling this way and have picked those particular products, it's all around 2 things. It's around custom built, meaning developer built through DevNet and applications you can build for your business. But we've also recognized over the last couple of years that tech partners and what they're building for their solutions, it's allowed them to monetize what they're doing, and it's helped us scale. So for those of you who are end users or customers, it's also helped from a cost benefit, so you're not having to buy a package of apps for government, a package of apps for a market. You can go through and pick out which ones that you would like to have. So with that being said, you know, I think we all know this. Real data and the delivery of business value is super important, and data continues to be in the news around who knows what when. So I will ask just really quickly, how many of you guys have bought something online in the last 24 hours? No one? How many times have your wife bought something online last week? I didn't want to be sexist, so I was hoping you'd help me out. So for that, I wanted to give out money chips, but something with the Gaming Commission here in Vegas. So I'll give you a Meraki chip. So there you go. And I appreciate you saying that. But I mean, if we think about it, and we've talked about the platform, we talked about cloud, at the end of the day, it's all about data and how you take the data and make it work for you as a business owner or for a partner. So I just want to dig into that just a little bit. I'm not going to read you the slides because I think you guys all know that this is a big thing for us all to manage data. But this is what our customers are asking. So as we meet with them, they're saying, we want to get complexity out of the business. We want to make sure that our IoT and OT operations are working together. We want to automate. We want to make sure things are safe and secure. And we also want to be able to leverage analytics to the business. So what does that mean? It means taking these APIs that we have in these 5 different areas and building on top of them. So for an example, and again, I don't want to give a sexist example, so I'm hoping you guys can follow me here. As customers talk about, you know, I love Meraki, but you can't see the license plates with your cameras. Or I like the Meraki product, but you don't have the staff, or you can't manage the scale. Or we may get, I like the Meraki product, but I don't see how it fits into our existing line of business. These are things that we've been getting pre-pandemic and post-pandemic around Meraki. And that's why it's so important that we leverage what we're doing in the marketplace. And if I take an example, again, I know you guys haven't shopped in 24 hours, all right, online, but some wives have, I got it. And we think about, you know, the Mall of America. You know, those of you in the US understand that the Mall of America is one of the largest malls, right, in America, perhaps the largest. And we think about, you know, what are they trying to do? They're trying to maximize their assets. They're trying to make sure that they're putting key businesses into the right areas. They're trying to make sure they understand how to control their rent. They're trying to make sure they understand who's coming in and who's coming out of the business. And they're looking at loyalty, right? So they're using our analytics to improve their marketing, their staffing, their rent control, and so forth. And by doing that, it's allowing them to see which wings of the mall are open, should be open longer, where should they put their key businesses, where should they take those mom and pop shops, right, who want to be in a mall but can't afford the rent, and where should they put them? And then more importantly, at this example in particular, they're looking at cameras and how can they make sure that they're looking at individuals coming in all the entrances, scanning them with infrared, and making sure there's nothing in their pockets or anything that can cause harm. So that's just one of the examples that we're doing across retail. If we dig deeper, we look at the base functions that we have, then we move to our core business. And before COVID, most of our conversations with Meraki were around network integration. How do I make network integration easier? What are the Meraki APIs? How do I download things around health? They were very business-specific questions. But then post-COVID, what happened is we had a boom in what we call the yellow section here. And it was questions around how do I manage people? How do I do smart workplaces? How do I work around loss prevention? How many of you guys have a smart space initiative or a hybrid work initiative at your work? Oh, you guys answered. Hang on. Coming through. Sorry it's not $10 at the Bellagio, but it's the best the gaming people would let me do. You get another one. You can take it home to your wife. There you go. There you go. Perfect. All right. Wouldn't it be nice to know, how many people are really in the office? How many people do you need to order lunch for? In the Meraki office, I know we get free lunches. It's a kind of an important thing, to understand that. Wouldn't it be nice to know how long people stay, where they hang out? And that's what we're hearing from businesses around hybrid work. And that's why some of the applications that are happening across a lot of our ecosystems partners are so important. We're also seeing from customers that they want to make sure that they can manage things easier. So like EAs. If you're a Cisco partner as well, you've heard the word EA, Enterprise Agreement. How many of you guys have heard that? And no one threw anything at me when I just heard that. Okay, so you get one. I'm running low. You're not going to get a second for your wife. I hope you don't have a second wife or we'd be in trouble. Oh, you got one already, right? Over here. Okay. All right, let me get you. So, how do we do EA management? How do we make sure that we make it simple for customers? How do we make sure that we're doing the right things? And, one of our ecosystems analysts who is here today works around that to make sure that we have a simple solution for your customers to make sure they're monetizing and understanding what they have around their enterprise agreements. And I believe he's right here in the back. There you go. I didn't plan that. I just want you guys to know I didn't plan it. Yeah. And then the second thing I want to talk through is around health and safety. I've had a lot of folks at the booth come up to me around governments. What are we doing to keep people safe? How many people are wearing masks? How many people aren't wearing masks? What's the spread of COVID in those areas? How are we making sure doors latch? So we're seeing those needed applications beyond just the license and being able to read it so we all get the $50 ticket in the mail, right? Has that happened to anyone, or does that just only happen to me? Probably only happens to me. Okay. So what does this mean? It means we've created a marketplace. And we've created a place for you to go, whether you're a customer or a partner, where you can pull up by product, by history, and there's a 2-minute video that I'm not going to bore you with because I know you guys are all going to come see me in the booth after this. I have really cool swag. And you can get your picture taken, the official Meraki picture, so I know you're going to want to come for that too. But it takes you through industries. So if you're in, what industry do you work in? My medical life science. There we go. I like that you had to tell him. He was like, here, for putting you on the spot. Okay. So you can search by that vertical. And you can find our ecosystem partners who can help you around there. And you don't have to worry about like a hard sales pitch for them, because I know a lot, if you're a customer, you're like, oh no, I'm going to click on this and I'm going to get a guy or gal calling me 10 times a day and telling me what my wife's buying from Amazon. No, you won't have that. You'll have the ability to go in. You have the ability to see a demo. You'll have the ability to look at use cases. And then once you go through that and you say, hey, I think this is right for me and my company, then you can go through and do the demo requests with the company. So it's a great way for you as business owners and as you as partners to explore what's out there so you don't have to build it homegrown. How many of you guys have used the marketplace? How many of you knew we had the marketplace? I'm going to go off script. Do you think you need the marketplace? Or are you not sure? Okay. Anybody else? I only have 3 of these, or 4, and the one I dropped, magical little squares. You better come on strong here soon. Okay. So I would encourage everyone. I had a customer come over to me. He goes, I've been a Meraki partner for 6 years. I had no idea about the marketplace. And so we started kind of going through things, talking about his business. And sure enough, by the time he left, he had written down a bunch of the companies. So that's really what this is all about, is connecting you with those entities, those companies that can help you monetize what you're doing and also help you get to your next level of what you need for your business. So this is a super proud moment for Cisco Meraki, because today, here at Cisco Live, we have the following ecosystem partners with us. And some of them don't have formal booths. There's others who are here as well. But it's really an opportunity for you to figure out, what does ecosystem mean to Meraki? What could it mean to me? What could it mean to my customer? And each of these have unique applications they do. Within the Meraki booth, we have Cognac, who are taking, if you come, again, after this, you may need an espresso. You know, I'm the midday, nothing like right after lunch. So if you need an espresso, we have the espresso machine working, and Cognac is doing, how long does it take to serve someone? How many cups do we use? How hot do we think the espresso stays hot? How quickly does someone come up for a second? How many people come up for a second? So they're doing some really cool things through their platform right in our booth. So I would encourage you to come get a picture, come get some good swag beyond my wooden nickels here, and also see some of our ecosystem partners. So, you know, I've talked a lot, and I've made it kind of fun and interactive, because I know this will shock all of you here. I'm not an engineer. I know it's shocking. I know I don't want to put you back on that. But I've really brought this out, and I'm so passionate about it. And it's actually why I moved from Cisco after 22 years to come run this team, was really ecosystem. And it was around the applications, because if you've been a Cisco partner for more than 5 years, you've heard us talk about ecosystem, right? How many of you guys have heard us talk about ecosystem? Yeah, or 20,000 times. You're so polite, and you sat in the front row. Did I give you one already? Okay, just making sure. But the difference here on this side of the house versus the traditional Cisco side of the house is the dashboard. It's the ability for you guys to manage from a single pane of glass. It's the ability for you to pick from multiple ecosystem partners and build what you truly need for your business to scale. You're not locked into, oh, I have to get a package for bioscience health. I think that's where we were at, right? I don't have to get a package for marketing. I don't have to get a package for security. You can pick the pieces that you want and have them all feed up through the Meraki dashboard. And that's really what makes it so magical. Just to give you an idea over, and these are stats, but just from a sales perspective, over the last year, and I've been here 8 months, so my year's been Q2 to now, we have increased revenue of average size deals by $425 million. So pretty big bump. But more importantly than that, the customer satisfaction for those customers who have worked with maybe a traditional partner and ecosystem partner has been 4.99. So I think there's 2 things from a partner perspective. It's the ease of use of bringing in what you need. It's the ability to expand the deal to playing bigger than you played. But from a customer perspective, it's really all about making sure you get what you need as well to meet your business needs. So with that being said, what are the next steps? First, you're going to go to the Meraki booth, and you're going to get this picture, and you're going to send it home to everyone at home so they can see what kind of fun you're having. Like my preteen says, yes, in my face all the time, so that's this. Then you can scan this code today to learn more about the Meraki dashboard and the Meraki marketplace, or you can come see a demo or speak to any of our ecosystem partners. I mean, this is really all about us getting it right due to the platform, getting it right with ecosystem, not having to manually chase things down. I know you have no idea what I'm speaking about, I know. But it's really about being able to see current data at a current time and being able to scale your business for your customers. So with all that being said, I will open it up for questions because I have 4 minutes. Or you guys can just run and get your selfies. Make sense? Not make sense what you were expecting? I do want you to know there is a second session on Wednesday that's more technical, that'll really take you in the nuts and bolts of building. And from the DevNet side, that'll be happening here in the DevNet Lounge as well. So for more detail on that. Yes?
I work with the U.S. Museum.
Yep.
NPO. And we're actually diving feet first into a whole hog replacement of our network with all Meraki equipment. And this coming from basically amateur hour for the last 15 years of Cisco, Brocade, Netgear, a Japanese company, Switch, I can't pronounce the name.
Huawei.
And all of this being just gutted and replaced.
Okay, so Christopher, you come see me at the booth. I'm getting you the really good swag, and I appreciate that. And can I ask why you did it? Because you said you had Brocade, you had Cisco, you had that Huawei company.
A lot of it is just we now have professionals that have been hired in to manage our network.
Yeah.
I'm a network engineer, and my boss is on the Meraki side. He just came in to replace our other boss that went to work for Disney.
Okay.
And it's just, we haven't had true professionals there.
Yeah.
Before. It's
Yeah.
all been whoever could be hired in that had even an inkling of knowledge.
Right.
So everything's just kind of kludged together.
Yeah. Did you guys hear what he said? He said just due to the capacity of the humans that were there, things were, correct? Things were kind of hodgepodge together, but now they're looking at the Meraki solution for the simplicity and the fact that he has folks there who understand it. How many of you guys are app developers? How many of you work with app developers? Okay. How many of you are partners versus customers? Can I ask? Partners? Okay, that's why you look so familiar to me. I mean, 22 years. How many of you are customers? Okay, can I ask you, are customers, do you think you're leveraging the full power of Meraki right now? Is that because you didn't know about the marketplace, or is that just because it's new to you, or?
New to us.
Uh-huh.
I didn't know about the marketplace either, so I will definitely dig into that.
Okay. And really, that's what this session's about. Okay. All right. I like that. Sonic Wall and Meraki. You guys can all stay who are like, really the Meraki advocates. I love this back here. How about you? What do you think you could do differently or more of?
Today we use a lot of the video.
Oh, video, yeah.
Probably want to step up a little bit more in the offices.
Yeah. Yeah, there's an IoT demo over there. I mean, there's so much you can learn. It's a little CSI Big Brother-ish, quite honestly, but data is power. I think a lot of people don't think that Meraki's in the AI business, right? Or that we're really looking at big data, but we are, and it's really through the use of our ecosystem partners. And so that's where we've stayed very closely with the Cisco model of making sure we have a partner-led and partner-with model to meet these new needs, even around, things that aren't the box drop and ship where we all did very well for 20 years. So, great. Well, with that being said, I have 20 seconds, so I want to say thank you very much. Hopefully this got your thought process going. If you didn't get one of these wooden chips and you're going to go home sad, I want to make sure I get these out because there's one on the floor too. They're very fancy. This gentleman was early and quiet, so you can have two because, yeah, thank you. And I just want to end with, for you who are customers, thank you for being a part of the Meraki family. We appreciate it. And then for you that are partners, we're happy to have you here. We're happy to work with you and help you build the next generation of the network experience. So thanks, everybody, for coming.
Hi everyone, thank you for coming today. So I'm DJ Cole, a technical marketing engineer in our IoT group at Cisco here. And today's session is sort of kind of a little bit more about the communication that goes behind what it takes to actually go quickly in a robot, right? So I'm sure you've already seen our robot race car over there from the Indie Autonomous Challenge. I'll talk about that in a second. But not only does your race car actually have to physically go 192 miles per hour, right? But it also has to actually be able to communicate when you go that speed. So that's kind of what I'm here to talk about, a little bit about the communication and what you have to think about if you were to program a race car and you kind of do your own communication, what that would actually take. So first, kind of an introduction. So this is the same car that you see over there. There were actually 10 of these made. They were part of an Indie Autonomous Challenge, which was a number of university students. About 25 teams actually started the competition, and then at the end there were 9 teams after they went through some elimination rounds, and they got to develop software that run on these 10 cars to go around the Indy Motor Speedway. Later they went to the Las Vegas Motor Speedway at CES, and they're continuing to go through some other events in the future. But this car is actually built on a real race car on the Dallara platform. So Dallara is kind of a well-known manufacturer of Indy light cars. But where the driver would be, in this car there isn't a driver, right? And you can actually see that over there if you looked at it. Instead of a driver, it is a network switch, computers, and sensors that drive this race car. Kind of inside the race car, instead of the driver, kind of the perception of the race car, is 3 LiDAR sensors, 4 radar sensors, 6 high-resolution cameras, 4 high-precision GNSS receivers, and those GNSS receivers are actually capable of like telling the telling the software where that car is within like centimeters, right? So even just GPS and GNSS alone, the computer can actually drive that car around the racetrack, which is really cool, right? But obviously there's limitations to that. If there's other vehicles on the track, if there's obstacles on the track, it doesn't know that, but it can get itself around the car. So it relies on some of those other sensors for positioning and obstacle awareness, things like that. And to make sure, like, if something goes wrong with the GPS, that the car doesn't just veer off and run into a wall, because that hasn't happened at all so far. It has, but that's part of the troubleshooting and debug process. And onboard that vehicle, in addition to all those sensors, we needed the network to bring back the data from those sensors. And one thing I should mention about the challenge is, these were the platforms. So these cars were developed as a platform of sensors. Each of the teams in this challenge actually was able to pick any of the sensors they wanted to use, right? So they built the software. They didn't need to use all of these sensors, right? I think a lot of the teams kind of focused primarily on GPS because that was the easiest thing to get the car to go around the track. And then they built in other sensors into their program, right? But they didn't need to take all of this data and process that and figure out how to drive around a racetrack. From the Cisco side, we had an Ethernet switch on the vehicle, and you can actually see that if you go over there. We have a Cisco IE5000 Ethernet switch, which can do 10 gigabits per second, and we actually chain that together in a port channel to do 40 gigabits per second to the compute platform on the vehicle. But the biggest thing is it was that 1 gigabits to all the sensors, gigabits per second to all the sensors on the vehicle, right? So the LiDAR, the cameras, needed 1 gigabit link to that computer to send that data fast enough. But that's all the communication on the vehicle, right? That's how do you get the sensors on the vehicle to the compute platform. Really sort of what I want to talk about today is you have all that data on that compute platform on the vehicle. What do you have to do to get that data from the compute platform on the vehicle to the wayside, right? And why you would want to do that is things like analytics. But not just analytics, you need to get the data to and from the vehicle for things like safety, controlling the vehicle, maybe a teleremote operation while you're doing your initial build out and debug and programming and stuff like that. And it's not as simple as you would think when you go from something like low speed in the lab to like a robot to something that goes as fast as a race car robot at 192 miles per hour. First off, how fast really is 192 miles per hour, right? How fast does the processing have to be, right? So, if you took like 1 second of latency on your network, what does that mean for a race car, right? Anybody have any idea on how far that race car will go in 1 second when it's going 192 miles per hour? Any ideas? Okay. It's actually 283 feet. So that doesn't seem like a lot, but when you think about that, every 10 milliseconds on your network is 2.83 feet that car went. And by the time you add on top of that, the car doesn't stop instantaneously, right? So, imagine you're a developer or programmer on one of these teams for this vehicle, and you see that the vehicle, has went off course or started having some issue. Not only do you have to worry about the network latency, on how you communicate that to the vehicle, right? And it's not as simple as just sending one message. But you also have to think about, the car can't stop instantaneously, so it takes you 283 feet of time at 1 second to just tell that car to stop, and the car still has to stop, right? Which may take 400 or 500 feet depending on the speed that they're going. At 192 miles per hour, it takes a long distance for that car to stop, even after it's heard that it needs to stop. So latency kind of is an issue there. And not only do you have to be able to do that, but when we talk about something like the Indy Autonomous Challenge that happened in Indianapolis at the Indy Motor Speedway, that's a 2.5 mile oval track. So not only do you have to have that coverage, you have to be able to provide connectivity all the way around that 2.5 mile track at the same reliability that you have anywhere. And a lot of robots today use LTE, but when we talk about race cars and racing, this venue has a DAS system built in for LTE, right? If you're in one of the stands around this track, you get really good LTE coverage. When you're on the track, when you're on the infield, in the areas where they don't expect you to have a lot of people, the LTE coverage isn't that great because it wasn't designed to work there, and it was actually designed not to work there because they really needed that bandwidth where all the spectators were. So you couldn't rely on that. So we actually, for this project, we deployed our Cisco ultra-reliable wireless backhaul solution, and these are actually the position of the 11 radios around that track. So all of the communication that you saw, between the switch and our radio and the wayside, all happened at these points along the track, which doesn't really have an effect on kind of the next part I'm going to talk about, but it's just interesting to think about. Not only do you have to have that speed, but you also have to move it around and do handoffs to each one of these between radios as you move around. So it's sort of like when you walk around here and you have the roaming, but it's a little bit more complicated when you go to that fast speed and have to go around so fast. So really kind of the point of today's lightning talk here is kind of share with you a little bit of the insight on what types of traffic do you see when you talk to robots over the wireless, right? And this could be a robot race car, this could be an AGV in a factory, this could be a little toy robot that you just want to drive around your yard, maybe a lawnmower or something, right? And this is kind of my classification on, there really is no standard, this is really kind of high level ambiguous, but there's a few different types of data that we see when you communicate. The first type of data that I want to talk about is the deterministic data. And the idea behind deterministic data is it's a little bit easier to actually show you the second one, right? So if you're familiar with using a messaging system to send data between two different processes, you basically send messages when something's changed, right? You say, in this case, you say variable 12 equals this, variable b equals 4, right? And every time you have a change, you issue a new command saying, change this in this other process, right? So imagine your two processes are, I have a message. Go away. So every time you have a change, you get a new message, right? And that works pretty well when you have lots of variables and a little change. But the difference between deterministic data is, imagine you're a robot race car, you're going fast, and you could potentially lose packets along the way on your wireless, and you also can't have a lot of delay. So what deterministic data is actually creating a data structure where you predefine in what position of that data structure you expect information to be, and sending that data every X amount of time, right? So in something like this race car, I think it was every 10 milliseconds. So rather than saying, the speed and the heading and the control, like how you want the vehicle to turn, like from a joystick, imagine if they're driving it manually, rather than sending each one of those updates, you actually just send that data continuously over the network in a predefined structure. That way, if you have any latency, or if you have any lost packets, you have that data every X period. And I think that's something that's that's a little bit hard to understand, but I mean, does it kind of make sense for people, kind of how to do that? Okay. And the next part, it kind of makes a little bit more sense. And then you have the other data, right? Like the non-controlled traffic. These are the log messages, don't forget to fill out the session survey at the end. Those are the log packets that don't really fit in any of them, but you also have to pass over at the same time. So you have these three different types of traffic, and imagine you're on an AGV, like this car or a robot or anything. You usually have all of these, right? Because you have the critical control traffic that you have to send, that like moving the vehicle or what a certain sensor is reading. You have the other things, right? Like maybe you want it to do this next, or the battery level, some things that aren't as critical, aren't time sensitive. And then you have all the other stuff, the log messaging, the debug messaging, things like that. But the deterministic data is really what you have to pass over the network to make something like a robot or an AGV in a factory work. And I kind of like to think of this as, you're basically sending out a packet every 10 milliseconds, and encoded in that data structure is everything the car needs to know. And this goes both ways, right? So it's both the car sending it and the wayside system sending it to the car. The wayside system is going to send something like a heartbeat, right? Saying, yep, you're good to operate, or maybe something's wrong, like I pushed the e-stop button, or I told you to turn left or right. The wayside system is going to send that differently. And it will just, it'll change the same position in the packet in that predefined data structure. And you can imagine this gets sent every 10 milliseconds. So, imagine you're writing a program, right, and you're sending this data every 10 milliseconds. Imagine you're at a very low, level protocol, and you want to send this data, right? Very basic level, like TCP, UDP. What would you think the best way to send this data is to make sure it gets to the vehicle? Any answers? How many people would use TCP to send it? One person? No one? How many people use UDP to send this data? One person? Two people? Okay. Well, definitely the best answer here is UDP, which to some people seems a little bit counterintuitive because this is stuff you want to get there. But actually, UDP is the best way to send this because imagine if in the TCP in the TCP session something happened here, right, and you had to retransmit a packet that basically pushes all of this data back, and you kind of get delayed, which is something that you don't want to happen, right? In a deterministic data stream, all of this data, just like a voice call, right? You don't want to know what someone said 10 seconds ago. You want to know what they said a second ago. You don't want to know what they said 10 seconds ago. You want to know what they said right away, right? Like you've already lost that data. It's the same data. Just repeat it. And that's kind of how the flow. And that's something that's kind of something that you kind of have to learn as you do this robot communication. And that's the example, right? So if you're sending this UDP and you have interference here and you drop a packet, well, 10 milliseconds later, that packet's going to get repeated with the same information, and it doesn't need to be resent. This is actually an example of the actual communication from that vehicle, from that robot, to the wayside. It's a little hard to read here, but essentially this is when that vehicle was using kind of that non-deterministic path, right? And you can, this is a little bit of gibberish in here, but you can basically see it sending commands over TCP stream. And what would happen is during their troubleshooting, they would get these kind of hiccups, right? There would be some latency or some lag in communication, and the entire stream would shut down because they were sending a TCP to the vehicle rather than sending that deterministic data. After this, the teams that were using this method of communication actually rewrote their entire communication to use that deterministic data structure and just basically send out UDP packets with predefined data types at a certain place in that packet to communicate across the wireless. And kind of the last thing to talk about is really the queuing of the data, right? So when you talk about all of these traffic types, imagine you have that deterministic data telling you, you're good to continue on the vehicle along the track with the vehicle. You have some of those that non-deterministic data that you need to communicate, like different variable changes, and these are things that you don't need to update that often, but you still need to communicate to the vehicle. And then you have those log messages, right? This is usually coming off the vehicle, but to the vehicle, it may just be, here's an update to this random thing that doesn't really matter, but you still have to pass it over the wireless at some point. Queuing that data is actually something, when you're talking about the wireless, that can kind of be a little bit complex. So most wireless systems use WMM for their QoS, both Wi-Fi and also our curb system, and they basically break that down into 4 queues. You have the voice queue, the video queue, the best effort queue, and the background queue. For the most part, the background queue isn't used. It's just these 3 queues that are used. So imagine that data goes into these queues and then has to go across the wireless, right? So you're the radio on the vehicle, and you have to say, well, I see all these other radios out there, and I need to know when I can transmit, right? So the way this works is each one of these queues has a different backoff time, right? So if it has something in this queue, right, this voice queue, which when we're talking about wireless communication and something like this, you're sending this every 10 milliseconds. So more often than not, you have something that you want to send out here. The idea in this voice queue is that the vehicle doesn't wait as long when it sees something, after it sees the channel is clear, after all the other radios stop transmitting, it doesn't wait as long to transmit that packet. So these packets will always get out first. And primarily for most radios, including our curb system, it won't aggregate these packets. So as soon as there's a packet waiting to go out, and it sees the channel's clear and it's waited X amount of time, it transmits that packet. So it's really important that these packets be a little bit smaller, and then they have to occur at a frequent basis, to be able to be sent out and be received by the other side. I use the example of 10 milliseconds, and usually these systems, they'll have a timeout, right? So if the other side waited 40 milliseconds and didn't see any of these packets, that means you missed 4 packets, right? And at that time, imagine this is being sent from the wayside to the vehicle saying, everything's okay, I don't want you to stop, you can continue moving. If the vehicle doesn't receive that packet in 40 milliseconds, or maybe 50 milliseconds, right? 4 periods times plus 1 more, it's going to stop, right? And how that vehicle stops can change a little bit depending on how the team's programmed it. It may apply the brakes and stop suddenly. It may slow down and move over or something on the side of the track safely, but the vehicle has to stop if it doesn't see that data. Mixed in with that is all that other data, right? So it sends these first. If it sees that the channel is clear for a little bit longer, it'll send these other packets. But the idea being is to use this structure is the best way that you can push this data across the network and reliably receive it on the other side, right? If we just stuck everything in these large packets like this and try to communicate it to the other side with those variables like you saw on that last slide, what's going to happen is you're going to get stuck. And once you get stuck, you don't get the chance to transmit onto the wireless. And that's going to leave you with, essentially, your 10 milliseconds packets are now being received in clumps every so often because they were large and couldn't get onto the wireless. So that's really why when you're designing these robot systems, even if it's something small, right, and you want to communicate that, small UDP packets that are deterministic, where each of them have the same copies of the data in each packet, is really the best way to communicate that information to the robot on the other side. Sort of the housekeeping slides at the end. First, I'll take questions and I'll go through these. So does anybody have questions on this? I know it's a lot to take in and kind of different for most people because not a lot of people use robots over wireless, but any kind of questions you have related to this? No one? You all are so quiet. Which either means, yep. Sure, so the question was on India Autonomous Challenge, did we have a backup type of radio? And the answer for this was no, right? So if you lost this communication, that basically meant that the vehicle had to stop. The way that you can kind of work around that is making sure that you have the right timeouts, right? So, first off, you have to figure out what your timeout should be, and that's kind of determined by how far can the vehicle go before you deem it's unsafe, right? So what is the reaction time, right? How far can the vehicle go when you say, I want to stop it, is acceptable for you? Once you pick that time, it's making sure that your timeout, right? So if you're sending packets out every 10 milliseconds and you want a timeout of 700 milliseconds, 0.7 of a second, then you can miss a lot more packets. As long as you set that to some point that's acceptable, if you set a higher or a longer timeout, you're going to get less this fault. On the wireless side, in our curb technology, we're actually developing a technology called MPO, where we actually can transmit that packet twice and then compare it on the other side and deduplicate it, so you only get 1 copy on the other side, but you send it twice. We're looking at that, and that's actually something, if you wanted to learn more about, if you come to our IoT area in the World of Solutions, we can talk about MPO and sort of what we're looking at on new products. But definitely an excellent question. Any other questions? No? Okay, good. Feel free to come up afterwards and ask. I know a lot of them sometimes are really specific to what you're doing and things like that, so happy to entertain those afterwards. With that, technical session survey. I think there should be a survey in your app afterwards if you were scanned in by the good gentleman back there with the scanner. If you did that, you should have a survey in your app. Today is Monday, so if you do fill out 4 session surveys and the final Cisco Live survey, you can get your chance at getting some Cisco branded socks from the material pickup area. You get points for every survey you complete. And I'm sure you've already heard this a few times before, but you get those points and it helps you get on the leaderboard to win some additional prizes. If you want to learn more about kind of Cisco ultra-reliable wireless backhaul or how we use wireless communication in industry, we have a few sessions. We're talking about one of our new products in this first session. Outdoor wireless, kind of a general overview, and this isn't specific to industry. We have a session on outdoor wireless. We're talking about how we use wireless for mining in this session. And if you want to learn more about Cisco ultra-reliable wireless backhaul and how we set up that mobility, like you see that kind of I demonstrated, you can go over to the walk-in lab area and go through the Cisco ultra-reliable wireless backhaul lab, which is actually kind of really cool if you've never played with kind of backhaul wireless systems before. Kind of the generic how to continue your education. Obviously here you're already in DevNet, so you got that check off. the walk-in lab's over there. Capture the flag conveniently right there. I can point to it. Also, this session is not recorded, but our other breakout sessions that are recorded you can view on CiscoLive.com. And of course, you're in the showcase, you know about that. If you want to book Meet the Engineer, I'm available, some slots left. You can go to the Meet the Engineer way down there in Bayside in the Meet the Engineer area and set up a time. With that, thank you for attending, and I hope the rest of your day here at Cisco Live is good for you. Good. I'm still
You
on.
had 20 minutes of time. You ended that with 10 seconds left.
Isn't that good?
Yeah, you killed it.
Welcome, everyone. Oh, that's very loud. I'm sorry. I'm John Kuchta, and it's great to have you here. Today, I'll be touching on some of the latest developments with the Meraki APIs and helping you connect the dots to leverage these new features and realize major cost savings, greater ROI with your Meraki deployments and your API-driven applications. I've been building network infrastructure since 1999. It might not look like it, but I have. Back then, Wi-Fi was 802.11b. IPX SPX was still a thing. I think StarCraft, the original one, supported that. And just in case your network wasn't TCP/IP. My first jobs in networking were pulling. They're probably some of the hardest, right? Pulling Ethernet cables through hot crawl spaces in August. Some of us, I think, have been there. Driving out to remote sites to troubleshoot something simple, realizing you brought the wrong console cable or power injector. Yikes, right? I'm happy to say we've come a long way since then. Over the past decade, I've spent time at some other networking vendors, and more recently with a Cisco Gold partner in VAR and MSP. In Southern California, I managed $50 million worth of infrastructure projects. We were doing major infrastructure upgrades, everything from Wi-Fi to SD-WAN to VXLAN. And of course, helping customers reduce their TCO and realize better ROI with those major upgrades. At Meraki, I help look after our API-first strategy and our API development roadmap. Hands down, of all the jobs, this is the best job yet, I will say that. Today we're going to cover some of the guiding design principles for our APIs, and then we'll dive into tools available to help you build infrastructure and extract intelligence from the platform faster than ever. And we'll also talk about a few new features that can greatly reduce the amount of time and work needed to leverage that Meraki intelligence in real time. So why API? Some of you are already using APIs, right? But this question does come up, and it's a fair question. Why API? This type of question comes up all the time with new customers. And even if you are already using APIs, I want to equip you with a simple answer you can bring into any conversation about APIs. APIs enable you to do two key things. First, make better data-driven decisions about your business. Some of these decisions are table stakes, right? Like capacity planning or measuring your customer experience with the network, right? But some of these are also bigger decisions about how you reach your customers and deliver world-class experiences to your customers. Then on the other side, APIs help you act on those decisions quickly, efficiently, experiment with new strategies, and then actually measure the success of those changes. Meraki does offer several APIs, 6 or 7. Today we're going to focus on 3 of them, right? You can imagine the different APIs as tools in a tool chest. Today we're going to focus on just the 3. Dashboard API. Those of you who are using APIs probably use Dashboard API. It's our general purpose inbound API. RESTful, it's our most popular API, used from everything from major deployments to day 2, day 3 monitoring. Webhooks, on the other hand, are an outbound API, also RESTful. We use those for event reporting and logging. And then we also have a streaming telemetry API via MQTT that publishes real-time streaming insights from things like our cameras and our access points. And we're going to start today with Dashboard API. For several years now, Meraki has offered the most generous API call budget in the cloud networking industry, of all cloud networking vendors by far. I checked just today to make sure that this was still accurate, and it is. When we launched Dashboard API v1, which is the current major version of our API, in August 2020, we offered 432,000 API requests per day. That's 5 requests per second for an organization. And that's about 4 times what you would get from Mist, and about 400 times what you get from Aruba Central. Then in July of last year, we doubled that to 864,000 per org per day. So with that budget, you could hand 1 API request to every single attendee of Cisco Live, and then every single resident of Las Vegas. you would still have budget left over. For comparison, Mist gives you about 120,000 in a day. That's not enough to cover Fargo, North Dakota. And we're seeing incredible adoption and growth numbers for the Dashboard API. Our customers love using it, and we're thrilled about that. They don't have to tell us because we see it in the data, we see it in the engagement data. In the first quarter of this current fiscal year, 500 different customers, not organizations, but different customers, grew their API consumption 100x or more. So imagine going to Starbucks once, and then for the next month, you go back breakfast, lunch, and dinner every single day, right? That's incredible. Then in the second quarter, we saw that figure actually double. 1,000 different customers grew 100x or more. You might be one of those customers, in fact, if you're using Dashboard API already, but I don't think I'd want to really imagine what that might do to my local coffee shop if that were happening there, right? So, quick question, does anyone know, have any idea how many API calls, Dashboard API calls we serve every day? Any guesses? 1 million? 1 million. Anyone else? More? 1 billion. 1 billion every day. Okay, 1 billion, 1 million. That's a pretty big factor there. Anyone else? 10 million. Okay. Well, on average, we serve more than 200 million Dashboard API calls every single day. This number is growing as our customers start to realize value from the APIs and see how APIs deliver value to their businesses. We're really thrilled to see this, obviously, and it's now I'm going to talk about a few of the ways that we're making it easier than ever to actually realize value from the APIs. First major topic is the way we design the APIs. If you've ever built an application based on APIs, you probably wrestled with some documentation, right? You may have even wrestled with some of the Meraki documentation, to be fair. But when we design and build APIs, we consider several different aspects, like performance and usability, and then the value that it actually delivers to our customers. These are a few of the guiding principles that we use when designing endpoints. The first consumer of our APIs is, of course, the developer that actually builds an application based on the APIs, right? But that's not just folks like you. It's not just our customers, our sales partners, our ecosystem partners. It's also our internal Meraki developers who are building the dashboard GUI based on those APIs. Therefore, the attributes and the parameters that we have in a given endpoint should be human readable and explicit, right? Self-documenting, so that when you're developing, you can spend less time figuring out what something means or what it does, and more time actually using it to get something done, right? So here we're investing in things like open API spec response schemas and good habits in naming and structuring the data. If you've ever used an API endpoint where every single attribute was at the very top level and it wasn't clear which ones were related to which other ones, right? That's not a very good design pattern, right? It's a little bit better when things are grouped holistically and you understand that, you know, all these radius settings, for example, are related, that kind of thing. Coincidentally, we also publish our API docs publicly. No subscription, no license, no hardware required to read the docs, to even interact with the dashboard. And this is pretty uncommon in the networking industry. Most vendors, you have to have a license, you have to have an account to even read the docs, right? So how do you know if you want to develop until you actually buy something, right? It's kind of seems like you're putting the cart before the horse, right? You can actually read all of our docs before you even spend a cent. And the next is that our APIs, and APIs in general, should surface the relevant information as quickly and easily as possible, right? So this can take many different forms. Sometimes it's organizing the information so that you get the business insights you need, rather than having to sort through arcane logs and statistics. And what we're trying to do here is directly answer questions that are relevant to your business, right? So when you have a concern, is everything okay? Can we effectively, accurately, quickly tell you, yes, it's okay, right? That's the goal. Rather than making you do all the work, gather all the logs, figure out is it okay or not. And the third principle is that for developers, filtering very large data sets down to relevant pieces of information is a lot easier than aggregating lots of smaller sets of data, right? It's easier. And so in many areas in the API where we're currently exposing information at the network level or the device level, we're bringing that up to the organization level, right? So you can see it across the organization, so you don't have to spend as much time making API calls, right? Now we're going to talk about some tools that help you deploy at massive scale. I have an example deployment here. I don't know if this is your size. Does anyone feel like this? Does this feel relevant? 225,000 devices? Sound right? When we talk about huge deployments, this is kind of what we're talking about, right? It's not a walk in the park. So imagine if you had to deploy this. Imagine if you were a single network admin that had to get this done, right? 50,000 access points as a single admin alone, I wouldn't really be thrilled about doing. But in this example, if you imagine like actually doing with Meraki APIs, let's say you maybe have to do, in order to get the config done, 10 API calls per device, right? So that's 2.25 million API calls to get all of this configured. That's a lot of API calls, right? Regardless of who you are, how big you are, who your software developers are, how many organizations you have, that's a lot. And at that point, it doesn't matter how low the HTTP latency is, it's gonna add up, right? Because every single one has a little bit of latency, even if it's very, very fast, right? Even if it's only on the order of milliseconds, at 2.25 million, it adds up very quickly. So to accelerate your deployment, some of you may have heard of action batches. With action batches, you can reduce this quite a bit. You can take the 2.25 million API calls and reduce that to, in real practice, maybe 30,000 different action batches, right? And that's gonna seriously cut down the amount of latency involved in your applications getting things done. Now, action batches, if you're not familiar, they let you take 100 different actions, up to 100 different actions, could be fewer, 100 different actions, and let you submit them all as one batch, right? So if you know that you have to deploy 100 APs, if you know that you have to set 100 IP addresses, that sort of thing, that can just be one API call. It doesn't have to be 100, right? That's gonna seriously accelerate your deployment. Now, if you had 6 organizations, right, you can run 5 action batches at a time per organization. So you can have 30 running concurrently. The upshot here, right, is that it really makes it feasible to do these major deployments in not a lot of time. Now, it's easier than ever today to actually use action batches, right? So has anyone here used our official Python library? Right, okay. Have you ever submitted an action batch via the Python library? Okay. So action batches take a JSON payload, right? You tell us what you want to do, that's a set of actions, right? But that's all JSON, right? It's not Python functions. So if you've never used it, that might be why, right? So with this action batch module, we're actually going to generate the required JSON body for you, and the syntax is going to be very similar to actually running the function via the Python module, the Python library today. So it should make it a lot easier to migrate applications that are already using the Python library to use action batches. That's the goal, right? At your convenience, do it a little bit smarter, a little bit faster, and a little bit more easily. So let's take a look at the two. Does anyone see the difference between these two? It's subtle. Just raise your hand if you see it. Seems pretty close, right? Yeah. But they are different, right? Now, on the left is just a standard library call, right? It's going to update the switchboard configuration, access VLAN 10, right? If you execute this, it's going to actually do the config. Now, on this side, the only difference is that there's this batch part of the module. The rest is the same. And when you run this, it's not going to actually change the config. It's going to generate the action that you can then use in an action batch, right? So now you don't have to write the custom JSON body, right? It'll do it for you. It's a small thing, but it really makes it a lot easier. Now, once you use this, you can append all of those actions into a list, and then you can submit those using the official Python function for action batches pretty trivially. So I mentioned that action batches support 100 actions per batch. It's pretty good. But if you've got that huge deployment, right, you're going to have more than 100 actions to submit, right? What if you need to submit something like 100,000 actions or 1 million actions, right? Or in the earlier example, 2.25 million, right? Well, even if you're using action batches, right? You might run into the scenario where some of that does need to be linear, not all of it can necessarily be concurrent, right? You might need to get your management interfaces set up in a way. You might need to get some VLANs set up before the rest can work, right? And now, in the client that you're building, you would usually have to go and build a bunch of logic into that client, right? To handle that, right? As well as making sure that you're only submitting things on the batch queue when there's space, right? So you're not just wasting your budget. Now, the action batch helper helps you streamline this submission, right? When you're working at that massive, massive scale. You just have 20 actions, you might not use this. But if you have 1 million actions, you probably should, right? This makes it easier to work with action batches, handling things like whether they need to be submitted linearly, taking an arbitrary list of like 1 million actions and then separating them into individual discrete batches, right? Submitting them on a queue without overwhelming your action batch queue, right? Not wasting your time and telling you over as it goes, how it goes. And also letting you say, for example, that a given batch is gonna rely on prior success from another one, right? It'll handle all of this for you. This will really help if you're at that level and just make your life a little bit easier. There's some links here which you'll be able to access in the PowerPoint when it's downloadable. There's a few key features here. First, it does actually create the batches from any arbitrary list of actions. You have 100,000, 1 million actions. It'll create all the batches you need. It will submit them, like I said, only when there's space on the queue. And it'll allow for either simultaneous, you want to do a bunch of concurrency, you can, if, for example, your deployment supports that, or linearly, when and if you require that. It'll even generate a JSON preview in case you want to see what it's going to do before it actually starts submitting, right? So you will still have full control here. So these links, like I said, will be available after the talk. Now I'd like to talk about data gathering and specifically doing it quickly and efficiently and at very, very large scale. We've recently released a few new dashboard API features that should make it easier to get this information quickly. And I'm going to take a look at a few of them today. There's many others, but we're going to take a look at just a few. The first one is the device statuses overview. Now, if you're monitoring your deployments, you're wondering how many devices are online, how many are offline. You're also concerned about which ones are offline, right? But if you have thousands of devices, right, you might have to make a few API calls to get all that data, right? But the concern might start with, is anything offline? Or is anything alerting? Now, if you call this endpoint, we're going to give you counts for each of those statuses. I'm not going to give you all the details, just the counts, right? So you can see 0 devices are offline, 20 are alerting, that sort of thing, right? This many are dormant. That way you can decide before you go and pull all the device statuses whether it's worth your time, right? If everything's online, nothing's offline, nothing's dormant, nothing's alerting, you probably don't want to go and check the status of every single device, right? Probably not. So this is going to simplify your client development because now instead of having to go and pull that and then filter that after the fact, right? Just make this one call, get the numbers. You see that you've got 20 offline. Okay, well now you can focus on just the ones that are offline. Organization summaries are another feature that's available now. If you're aggregating data across many networks, you're probably making a lot of API calls, right? You've probably written an iterator that does it for one network and then does it for another network, right? The organization summaries can do a lot of that work for you, bringing together the different networks into a single kind of overview, a single summary, really, so you have a better idea of what's going on very quickly and easily. Usage histories are another major recent development. If you want to see how your client data usage, your bandwidth utilization is going, how your uplinks usage is going, you can get that history. You don't have to pull this in real time. You can pull this once a day, once a week, right, at your convenience. You can go back about 30 days, right? So you don't have to make a ton of API calls to get this data constantly. You can do it over time. And of course, you can plan for capacity changes with this. You can baseline and see, are my clients suddenly using a lot more data than they normally do? Am I using a lot more uplink than I normally do? Or am I using a lot less uplink than maybe I thought, right? Why provision a gigabit circuit at who knows how much, right? If you're only pulling 200 megs, right, on the regular. So you can monitor and analyze your trends with less frequent polling, right? That's the takeaway here. The next one I'm particularly proud of, this is the network topology endpoint. Some of you may have pulled LLDP and CDP information from devices before using our API. Can I just see a show of hands if anyone's done that? Has anyone used the topology endpoint? Have you heard of it? That's okay, that's why we're here. So the topology endpoint takes the LLDP and CDP information from all the devices in the network, right? All your Meraki devices, the whole network. And it puts them into a single response. It's not paginated, right? It's a single response. You can see all of it, and it's going to be organized into a list of nodes, right? So that's the devices, and then a list of links, the connections that we've detected between them. And you're going to get the context that you need when you're actually looking to monitor, did my topology change unexpectedly, right? This also is something you can pull over time, identifying, did something change unexpectedly, right? Again, you don't have to pull it on a per device basis. Now you can do it for the whole network. Oh, okay. Damn. I'm really happy about this one. Organization switchboard configs. You've probably pulled switchboard configs. You've had to get them on a per switch basis before. Now you can get that at the organization level, right? Saving yourself a lot of API calls. In real world deployments with large organizations, 87% speed increase. So we're hoping this can save you quite a bit of time. Filtering large data sets. There's more filters in more places now. So when you get those organization level things, you can filter. You can filter to the networks, but you can also filter based on things like product types, statuses, tags, right? So you can focus on just the pieces of information that are really relevant to you. If Dashboard API is a pull service, right? Webhooks are a push service, right? We're alerting you proactively. While we can already deliver many types of events via webhook, one of the challenges that you've probably seen if you've tried to actually connect this with other services is that every service has a bespoke format for that JSON data. Does anyone run into that? And you're kind of wondering, okay, well, how do I connect these two? Well, build an Nginx proxy and then remap the fields, but that's a huge pain. With custom webhook templates, you can tell us how the data is supposed to be formatted, and then we will use that and actually send it. And we support body customization, we support header customization. So for example, you want to send it to Splunk, you want to send it to Splunk HEC, you can tell us what the authorization header is going to be, and you can tell us what the format needs to be for the body. In other words, no middleware, just a direct cloud-native integration. And this is the last piece, custom computer vision models. Has anyone here used MV cameras? No? Some of you, yep. So video is a great source of information, right? But usually analyzing the video is very resource intensive, right? And piping all that data is going to be expensive. I mean, especially with 4K video, that sort of thing, right? And processing video is honestly complicated. So if you have that infrastructure in place, great, but it's still going to take some time to process, and that can really delay your ability to react, especially to things that are evolving in real time, right? So what if you weren't restricted to what came out of the box with your camera, right? What if you could use your camera to detect custom-defined objects, right? And then tell you via MQTT when we found those things. And what if you could do it without having machine learning experts? Well, that's where the custom CV models come into play, right? Now, you already know that Meraki MV can do object detection, desks, people, vehicles on the camera, right? So you don't have to pipe the video back. But with custom CV models, you can tell us what to look for, right? So when you upload it, and you can of course do this via API, right? When you upload the custom model to us, then we deploy it on the cameras very quickly, very scalably. And then the cameras will detect what you tell us to detect. And then again, using MQTT, stream those to you in real time. No video infrastructure required. That's it. There's really just a few final thoughts here. APIs are going to help you make and enforce better business decisions. It's easier than ever to leverage Meraki APIs. And we offer the right tool for the job. Dashboard API, webhooks, MQTT, and a few others. If you want to take a look at our documentation, this QR code you can scan with your phone. I'll get out of the way. And thank you very much for your time. Appreciate that. Thank you very much.
All right. All right, everybody, thanks for joining. This is getting started with IaC and Terraform. So if you are an advanced Terraform practitioner, this is probably a little bit beneath you. But if you're just getting ready to get started with Terraform, HCL, understand what it's about, why is it the new hotness, you're in the right place. My name is Quinn Snyder. I'm a developer advocate with Cisco DevNet, and I focus on cloud networking and infrastructure as code. The PDFs will be posted. You guys have seen this before. If you join in the app, you can join the discussion. There's a WebEx space that I'll be moderating for a little bit if you have any questions, and you can download a PDF of this presentation as well. So we'll start with a little bit of background about what HCL, or what Terraform is, what HCL is, a typical Terraform workflow, and how you build and construct Terraform files, or what people will informally call as Terraform plans, and what the control structures are like, how we use resources and data sources, how we connect to endpoint resources, and then we'll dive into a hands-on demo where we'll actually show Terraform provisioning, a couple of things inside of an ACI fabric. So it's going to be high level on the ACI. I don't want to get lost in the weeds on ACI itself, but it makes for a really nice demo because of the GUI and the way that it reacts and things like that. And then we'll have some wrap up. So infrastructure itself, infrastructure's code as itself is really the act of managing infrastructure through configuration and definition files rather than like click ops or moving through it. A lot of network engineers have a hard time with IaC because we've been doing code with iOS and NXOS and XR for a while. In reality, what happened is as we started moving to the cloud, you look at the cloud portals with AWS and Azure and things like that, a lot of it was ClickOps driven. You go to the console and I want to create a VPC and I've got to assign security groups and things like that. It was very tedious. So out of the cloud really was born this whole idea of how can we configure infrastructure without that ClickOps nature. Now, because of things like Terraform, need to be natively multi-cloud, support AWS, Azure, GCP, and our on-prem infra, it only makes sense to extend that same capability running with a definition file with a single syntax that can affect multiple instances or multiple locations within our infrastructure. So Terraform was created by Hashi in about 2014, and like I said, originally it was designed as a cloud provisioning tool. A lot of the cloud guys were all in on this. It made it a lot easier than clicking through the AWS console. But as it's grown, it's really meant to be a full lifecycle data center infrastructure management tool. Now, the caveat with this is that it is written in Go. There's pros and cons to that. For anybody who's done any level of programming, Go creates a single binary file, so it's all compiled and you execute it, you move the file into your path, and you're good to go. The problem is that there's no real good native Go SSH library. So Carl Montanari has put together Scrapply Go, and there may be a few people who have used that. That's not incorporated into Terraform. So the only way that Terraform can interact with infrastructure is through REST APIs. So from a Cisco standpoint, that's your ACI, your MSO, your DCNM. We have a RESTconf plugin. There's a few other tools out there, but there's no device-by-device configuration with Terraform. So that may strike it off your list immediately if you're looking to manage your Nexus switches or iOS XE routers. It's also fully declarative. Now, what I mean by declarative is the fact that I don't have to know the commands that I'm entering in the device's native language. So, like if we think about Linux bash scripting, declarative means that I just say install a file. Procedural means that I have to say apt install blah. So, Terraform is a fully declarative end state tool. I write what I want the infrastructure to look like. It will combine all of the Terraform files together and then spit out the end state every single time the same way. I will cover a little bit more about comparisons between Ansible because there's some FUD out there that I want to clear up a little bit. But for now, it's an end state declarative tool. A typical Terraform workflow, if I'm provisioning infrastructure with Terraform, first I download the binary file, install it to path. There are some tools out there that make it a little bit easier. TFEnv is a way that I can manage multiple versions of Terraform inside of my workstation. But for all intents and purposes, you download it from terraform.io, put it in your path, and you're off to the races. We create our configuration file in HCL. We then do a Terraform Init, which we declare the provider or the tools that I will be using to connect to the infrastructure at the top of my HCL file. I do an init, and it downloads it from the repository online and initializes the project. When I say project, think of that as a folder. All Terraform files within a single folder will be mashed up and put together, so I separate projects with folders. I'll do a Terraform plan, which goes out, looks at my Terraform configuration, compares it to what exists in the device itself, and says, here's what needs to be added, changed, etc. I then do a Terraform apply, which applies the configuration as I've defined it in my Terraform file, and applies it to the end device or devices. And that could be one or more clouds. I can put multiple providers inside of a single HCL file if I choose. So I could work with AWS and create VPCs, and I can manage DNS with Azure in the same configuration if I so choose. What the advantage that Terraform has over other utilities is this piece right here, the destroy action. Because Terraform is natively stateful, it tracks and says, I have gone from point A to point B, here's the state that I've applied, and I'm going to track that. If I do a Terraform destroy, it reads that state file in and says, I want to remove what I've created. So that state file is good and bad. If someone goes in, creates a resource with Terraform, and then someone else messes with it in the GUI, Terraform doesn't know about the changes that were made outside of Terraform, and you can have problems with that destroy action because it's tracking the state. So it's positive and negative. So be aware of the state file, be aware that it is stateful. HCL, probably the hardest part in everyone that I talk to says, how do we learn HCL? How do we get that feel for it? Everyone loves YAML because of all the indentations and white spaces, it's human readable. This looks like a blob of code, especially for network engineers. This is terrible. The nice thing about it is I don't have to go through all that performative 2 tabs or 2 spaces, whatever, to indent on my YAML. It's natively braced, so it groups things together. It's composed of arguments and blocks. So in yellow, I've got arguments. It's a simple variable assignment. This variable is this value. A block allows me to define multiple assignments inside of one thing. So in this case, this is a resource block. A resource allows me to provide configuration to an end state. You'll see data sources, which also allow me to read in configuration. In this case, it's a resource block to configure a tenant. I have an assignment that says the name is var. I'm reading in a variable, and that variable's name is tenant, and I have a description. Because I'm curly braced, I don't need to worry about white space or tabbing or anything like that. As long as it's inside the curly brace, it's mapped to that block. The other nice part about it is, no matter how I write this, I can run Terraform FMT on the file, and it will clean up all of that nonsense for me. So I could write really ugly code, and Terraform FMT will clean it up to make it look like this every single time. All plans are of similar structure. You will start off, and I don't have it here, but you'll start off by defining the provider you're using. In this case, we can read in configuration. Like I said, data, you see the difference between data and resource. Data reads it in, resource applies configuration. So we can use those values for other things. It's a dotted notation. It's a nested dotted notation. So follow me on this one for 1 second. If we look at the green, we have this resource that uses the MSO schema. So I'm defining a schema inside of MSO. You don't need to know what that is. We're just defining it. And we've called that schema locally relevant in this file, schema object. Now, if I want to reference that later on in my Terraform file, I just use the dotted notation like I'm using a Python SDK and follow through. So I've got MSO schema that's nested up top, schema object, which is the name, and then template name, which is the variable that or the argument that I've given template 1. So you just nest through that. So instead of doing all that tabbing as I would do in YAML, I write one dotted notation and I'm done. The other thing is that for a lot of these things, you'll see this .id value that gets exposed as part of a resource. With things that are nested, so within ACI we have tenants, and a tenant has a VRF, and a VRF has a bridge domain, and a bridge domain is a subnet. That's nested tree. I need to link maybe a VRF to a tenant name. I don't want to have to type in the tenant name every time. That .id value is exposed. All I have to do is reference the .id for that specific resource, and I'm off to the races. You can do some basic programmatic loops just like you can in Ansible. So in this case, I have this variable called switches. I've defined a list of switches there. I can reference a for each value, which says loop through all of those switches. So for the variable name, var indicates variable. This variable name is switches, so var.switches. For each is going to loop through all of the switches inside of that. Similarly, if we look at the IP and role, I've defined those as part of my variables. So I say each value of IP with each iteration of the switch. So you can do some basic nested things inside of HCL, just as you would with any other programmatic language. Getting to the declarative versus procedural pieces. In this case, there's a lot of resources out there that say Ansible is something that is procedural, and Terraform is declarative. That's wrong. They are both declarative. I say what I want the end state to be, and it will do that. The difference is that Terraform is end state declarative. I define what I want the whole thing to be, and Terraform figures it out. Ansible, I need to know a priori the steps that I need to take to get from A to B. So I need to define A first, then B, then C, then D, and if it's not in that order, then sometimes Ansible will fail. You'll get halfway through and you get the retry and you've got to roll back and all the error catching and things. I don't have to do that with Terraform. They're both declarative, but one is declarative at a task level and one is declarative at the state level. And finally, you all may be thinking, well, we're just writing, it looks like some nested JSON. Where's my code? This is code. The power of things, the higher level abstraction tools with IaC, like Ansible, like Terraform, is I don't necessarily need to know all the ins and the outs of what goes inside to make that work. But if I define something with Terraform or Ansible, and I take that away, I have a record of the configuration. It may be in Terraform HCL, it may be an Ansible task, but I have a record of what that end state is going to be. That's code. That's portable. Now, once I've got all this done, I can snap it into a VCS like GitLab or GitHub or whatever. I can run some CI projects on top of that. Atlantis.io if you're looking for Terraform automation for infrastructure. IaC plus VCS, I've got CI/CD pipeline. And because I've used a sample modeling language, I can create those kinds of things. So, I'm going to jump into a little bit of a demo. Does anybody have any questions before I get into that? All right. Oh, Mikey. All right, so I knew this was going to time out, so hopefully it comes back. I have an ACI fabric that will log in at some point. However, we can focus on the right-hand side. Yeah, right-hand side here. I have a Terraform file here that is just something very simple. So in this case, all I'm doing is creating a tenant object. At the very top here, I've defined that my required provider is Cisco DevNet /ACI. That's the provider that I'm working with. And when I do a Terraform init, oh, come on. Get that login. All right, so inside of this folder, I'm in this 01 intro. My first step is always going to be a Terraform init. And that's going to go through, it's going to read in the required providers, download them from the Terraform registry, install them into a folder. In fact, what we will see here is we have this .terraform folder. That contains all of my Terraform provider information for the resources that I've defined. It also has this really nifty key ID here. Every Terraform provider that is submitted to the Terraform registry is signed by the GPG key of the creator. It downloads that key with the when you install the provider and then compares the two versus what's on the registry versus what it received to make sure you don't have any man-in-the-middle attacks there. So you're getting an authentic, genuine provider. The next part here just defines the requisites to be able to talk to my ACI fabric. In this case, I have a reservable sandbox that is pointed to this URL with this username and password and credentials, and all I'm doing is creating an ACI tenant. It's going to be called QMS Devlet 2785-01, and I have a description assigned to it. So, let's see if I can log this in. Now, first step, I've done the init. Now we're going to do a Terraform plan. This is going to read in the configuration that I've given in the Terraform file, compare it to the end state of my fabric, or what exists on the fabric, and it says I'm going to create these things. In this case, anything with a green plus is a create. A red minus, it's a delete. So we have some things. It's going to append an orchestrator tag so I know it came from Terraform. It's going to have a description. There's a few things that can get filled in here on the bottom, but the important part is the tenant name. So now I'll do a Terraform Terraform apply. I'm using bad syntax here on purpose, and I'll show you here in a second what we can do to streamline this, but it's going to ask if I want to apply this. I'm going to hit yes, and lickety-split, we have our tenant created. So we've actually done something there. The beautiful part about this, and going back to that whole MACD thing, I can do Terraform destroy just fine. It's going to say, are you sure? Yes, Windows, I'm sure. I'm going to hit yes. You can see that there's a red minus. It's going to delete those things. And my tenant is gone. So I have a full MACD, well, mostly the creates and the deletes, present inside of Terraform as itself. So I'm going to move to another folder. And I've separated these on purpose because what's going to happen here is in O2, I have two different files here. I have this main.tf, and I have a variables file. All I've done here is I've abstracted away the configuration, whereas before they were hard-coded variables. Now I'm just referencing a variable prefixed with the var dot something that is going to be pulled in from another Terraform file. Now, I don't need to tell Terraform to use the separate variables file, because when I put those two files together and hit a plan or an apply action, Terraform says, I see two Terraform files, they're going to go together, I'm going to mash them up automatically. So I'll do an init here. The variables, now I do want to highlight this piece here. And this goes back to that dotted notation. So we see here I've got var.user.username. If we go back to our variables file, I have a variable, and that's how we get that var prefix. The variable name is called user, and inside of user I've declared as a map with username, password, and URL. So var user, username, password, and URL are what align here inside of that provider configuration. So you just got to mesh the two up, and that dotted notation makes it a lot easier than, again, all the tabbing. Then I've just abstracted away the tenant name. Instead of hard coding it, I'm just doing var.tenant, and that variable is given here in my tenant variable. So we'll do a Terraform plan. And it says, okay, we're going to mash these two up. There's my variable name, and we'll do a Terraform apply. Boom. I now have that second tenant that's created. I'm going to leave it up just for grins. And we're going to move into the third folder here, 03. And in this case, I have something similar. The main file looks exactly the same. I'm referencing variables. I'm creating a tenant. We're done. However, in variables this time, I don't have a default value for the tenant. I've defined it. What's going to happen? So when we get in here, we'll do a Terraform Init, and eventually what you'll realize is that you're going to need to invest in a lot of good keyboard switches under the I, N, and T if you're doing a lot of Terraform. We'll do the init here, and we'll do a Terraform plan. It saw that there was a variable, but there's no value. So it's going to prompt me to say, what do you want to call it? I'll just call it QMS dev lit 2785033. It says, okay, we're going to create it. Now, here's the important part, and I've done this on purpose. Anybody who's used Terraform in the past is going to see, well, there's a way that we can guarantee the state here. But if I wanted to apply this Terraform plan, it's still going to ask me for that variable. The important part about Terraform is that a plan action is just that. It reads what's going to change, but it doesn't store anything yet. So here, if I wanted to call it, we'll just call it QMS 03333, that's different than what I put in. But when I apply this, it's called what I called during the apply action, that 0333. That can be a problem. The better way of doing this, and say I want to do a Terraform plan, we use this thing called an out file. We'll call it tf.plan. This is going to save the state. This is going to create a list of instructions to follow through in the apply. So I'm going to call this QMS dev lit 278503. Two things I want to touch on here. And I know I'm running short on time, so I'm going to make this quick. Terraform does not handle the GUI center of changes. With Terraform, I don't get that drift of state that I would normally with Ansible. I can't just say move from A to B and shift it. Terraform is meant for immutable infrastructure. So it says that I'm going to change it. It's a yellow tilde, the color's a little off, but you see this plus minus. It's not changing the tenant name. It's deleting it and recreating something new. So be aware when you work with Terraform, it's not going to change things very well. It's going to rip and replace. So there are implications in your infrastructure, especially in prod, where that can be a problem. So be aware of that. The one last thing I want to hit on with this is if I do a Terraform apply and I call the out plan, it's not going to prompt me this time, because that out file saved the list of instructions that I told it to follow. It's going to apply what I originally told it. The other piece here to note is that whereas before we had one added or one destroyed if we did the destroy action, you can see and it reflects that we used immutable infrastructure. It didn't drift it, it didn't change it, it removed it and recreated it. But it followed the file in that out plan, and now I have this devlit 2785.03 tenant that has been created. So that was a real quick high-level overview of Terraform and some of the things there. I do have a workshop that will be running tomorrow morning. I think it's at 10 o'clock, where we do some hands-on stuff. And you guys, I will give the repo. And in fact, I will post in the WebEx space a repo with all of this code in there that you guys can use and play with on your own. You can use a DevNet sandbox. You can use Reservable, always on. If you've got your own ACI simulator, you can use it there. But I will post the link to the repo of all this code where you can play with it yourself. With that, I think that's about it. The only thing I want to say, fill out a survey. I do appreciate any feedback, good, bad, or otherwise. Make sure you fill them out because you can win points and you get socks. Learning and certifications, Terraform is going to be a valuable part for any DevNet certifications as they start moving. Terraform will probably be on there, so you might want to learn it sooner rather than later if you're looking to certify. Cisco U and the learning certifications over there will take care of all that. And like I said, there's lots of sessions on Terraform. There's a lot of stuff on the DevNet website, ACI, MSO, DCNM, and a bunch of others that all cover Terraform in depth in the variety of APIs that are there. So, thank you.
Did it do the create and destroy because it was the same script run a second time?
Yes.